Yes, I'm here to talk about AWS, building scalable systems for Drupal, but it can be applied to other uh, systems. It doesn't have to be Drupal. I'm gonna explain that when we go on. But briefly about me, my name is Mika Tuhkanen. I live in Helsinki with my wife and 4 kids. I work as a Drupal tech lead in Siili Solutions. We have office here in Helsinki, Oulu, Poland, Germany, and a few in States. I mainly focus on Drupal, on my daily business and different cloud environments. And well, currently I'm also doing this automated testing module. So about AWS, it stands for Amazon Web Services. It provides cloud computing, but the key thing about it is that it provides more than servers. It provides services that you can use. So here is a typical case of a somewhat small project that you have Drupal, Apache, MySQL, memcache files, and cron running on the same server. So it's getting a bit crowded in there. So what if we could just have the Drupal and Apache on running on the actual web server and move other stuff to somewhere else? So there was this customer case that got me into looking more deeply into AWS. That we had this Finnish company that needed Drupal commerce website that has different amount of traffic depending the time of the day and the day of the week and so forth. So they might have like really low amount of traffic, for example, during the night, but really high amount of traffic if they have like a selling campaign. So thus we needed to have a system that can handle that and scale automatically so that we don't have to do manual steps in order to keep the site running. And also we didn't want to maintain those critical parts ourselves or by hand or write a custom code for it, because it's time consuming and time is money. So why why move stuff from the server to services in AWS? From the sales perspective, you get more reliability because you move some of the stuff or move the responsibility of certain things to AWS, and it's their responsibility to handle it, and they do it really, really good. And they have a lot of those services already, for example, the database, caching and such. And with the services, it's easier to sell to the customer because you don't need to make any custom solutions for it. And as a developer, it's good that you can actually focus on writing the actual product and not worry about the tools that you need to create when building a scalable environment. And as a maintainer, after the product has been launched, you kind of feel safe that those critical parts are handled either the AWS, and it's kind of like self-sustaining, that if something goes wrong, the AWS usually automatically handles that by either like spawning a new instance and so forth. So the key points about this thing is that we want to do less server hosting and focus on the actual product. using services instead of servers when it's possible and wise. Building a high availability product or system that can handle different amount of traffic without manual work. And then also that AWS provides tools to reuse the environment setup, so you don't need to always manually by hand click through different services and systems on. So, and you can create different kind of templates for different environments. So basically you have a JSON code that you apply to the AWS, and it creates those services for you. And we're gonna look more deeply into load balancing, database, files, caching, cron operations, and how to deploy the code in a scalable environment. So, first we have the elastic load balancer that distributes the traffic to the Drupal web servers. These web servers are basically in AWS EC2 instances that you have the Drupal and Apache running. And then we have the service, kind of like service layer there. We have the files that are hosted in S3, the RDS for the database that has usually MySQL, and then the Elastic Cache service that can handle the caching, for example, if you want to use memcache or Redis. And then we need to have different web server for running the cron, because you cannot really, or you don't want to run the cron on the actual web servers, because you might have like 10 of those. So running the same cron jobs on every server is usually a bad idea. And also the cron server can act as an access point for admins. And for example, if you need to install additional libraries to the server, you can do it there, and then you don't bloat the actual web servers with the extra stuff that only the admins need. And also you can have an IP limitation that admins cannot log in through the web server, but they can from the cron machine. And then the load balancing. It's basically a two-part thing. The first part is the auto-scaling group that handles the spawning of the new web servers, EC2 instances. So in there you can configure that, okay, I want to have 2 servers, but if the CPU usage, for example, goes high, it spawns more instances, or that you only have like 1 instance during the night, but when the office hours kick in, it spawns more instances, thus being able to handle the traffic. And then we have the elastic load balancing that keeps track of all of your web servers automatically, so you don't need to have like anything pinging those servers. So it automatically distributes the web traffic through those web servers. And so thus you have like a single access point, the load balancer that distributes the traffic to these instances. But if you have like a really big site and you want to have certainty or high availability no matter what, you can use the AWS Route 53, I think it was called, that you can under that make multiple load balancers in different regions. For example, if a certain region goes down in AWS, it's still gonna be operational. But yeah, that's so basically you can like scale it up for like really big sites and really have like a high availability. And then we have the web server, which is like I said, EC2 instance that only contains Apache and PHP. And the thing about here, when you're if you're gonna create this scalable system, is to have basically everything all kind of already installed on that server, because you can do it that way, that when the instance spawns up, you install the Apache and PHP, but that increases the time when the actual web server is available for the traffic. So thus keep in mind that you should have most of the stuff ready there. And yes, then to the service layer. First, we're going to look into the database that in AWS it's called RDS, which stands for Relational Database Service. It's scalable, so you can increase the performance of the server without hassle. It's just few clicks in the AWS console in the UI. And of course you can do it using APIs, but yeah, basically it's really easy to scale it up. It also has support for replication, so you can have a master database and read replicas. It automatically takes the snapshot of the database, so you don't have to manually handle that. And also you can enable AWS as a multi-availability zone. So if a region goes down, the AWS will automatically spawn you a new RDS instance. So thus having a high availability on that, and also that you don't need to manually handle it. And then the RDS supports Aurora, MySQL, MariaDB, Oracle, PostgreSQL, and Microsoft SQL. And also if you have different AWS account for, let's say, staging, dev, and production, you can share the RDS snapshots between the AWS accounts, so you don't need to manually copy and paste those databases between environments. And then the files. Since we didn't want to use hard drive that is mounted on every web server instance, we moved the files to the S3, which is basically like a service where you can host the, for example, node images and also the compiled JS and CSS. There's a module for that that provides additional file system to the Drupal and kind of takes over the typical file layer and handles that. And S3 has also support for SSL and file versioning and API. And it's really easy to sync the files between the buckets. For example, here is a single line command that copies the files from the production environment to the staging environment. And then the caching. In this customer case, we placed the memcache to the Elasticache service, and it also has the high availability support that if the memcache server goes down, it will automatically spawn you a new one using the same port and host, so you don't need to manually handle those. If, for example, if a server dies, that you would have to change the settings in Drupal. And you can have multiple clusters that have multiple nodes of memcache, so you can spread the usage of or the Drupal bins through the different memcache nodes, like so in the screen. And then a bit about the cron machine. In this customer case, it was the web server for running the cron jobs and the backend for the admins. For example, we needed to convert Word and Excel files to PDFs, but we didn't want to put those libraries on the actual web servers, so we installed them here, and thus keeping the web servers as light as possible. And also when you're deploying code in Drupal, you most often need to clear the caches, update database, and so forth. So this is a good place for that. So for example, if you have a deploy script, run the database updates only in here, not on all of the environments. And then since we don't know how many web servers we have or where they are actually located, we need a way to deploy the code. And that can be done by deploying this deploy package to S3. And we do it so that we have this custom script that checks out a certain version of the code in a separate folder and possibly does something like compose or install on it and then deploys it to the S3. And from the S3, using the code deploy, it can be deployed to the instances. But if you have, for example, GitHub, you can skip the S3 phase because the code deploy directly supports the GitHub. And then using the code deploy, we deploy the code to the web servers. You can automate this using the terminal, but I find it that using the UI in the code deploy provides more output of the actual deployment, that how did it went, was there errors, and so forth. But you can do it. You can do this on terminal alone. And so when the code is deployed to the web servers, you can, for example, trigger the code that okay, go to the cron machine and run those updates. And here is an example of the app spec UML that is used in the code deploy to deploy the files in certain locations into the web server. So in there you can see the files. So as it creates the package of your code, it deploys those certain folders there and sets the permissions to those. And then the code deploy supports different kind of hooks. For example, if you want to shut down the Apache enable maintenance mode, for example, you can have custom scripts there to do it for you. So basically everything can be automated, that you just run the deploy script and boom, it does everything for you. And then since you kind of have a lot of going on, you have different servers, different services running, so you want to be able to monitor the performance and such. So the AWS also has tools for those. Like in here you can see the CloudWatch, where you can monitor the instances, the performance of the RDS and such. And then the access log can be stored in the S3, so you can see the access log without going to the individual web servers. And then you can kind of automate the whole setup of the environment using the AWS CloudFormation, where you either write the config file using JSON or use a CloudFormation designer that looks something like this, and that generates the JSON for you. But there are a few issues with this system. Varnish is not supported by default, so you have to manually keep track of the instances for Varnish if you want to, because the load balancer IP changes, so that can be a problem. And then the S3 support, the S3FS module. Some of the other contrib modules have issues with it because they can have implemented the file handling in a way that doesn't support the chosen file system. And also I've experienced that there might be some permission issues if you sync the sync the files in S3 between the buckets. And then you like the idea but don't want to use services, that's fine. The AWS provides you with multiple SDKs and APIs, so you can do it yourself. What does it cost? AWS has this calculator that it's a bit complicated, but you get the ballpark of how much would this kind of system cost you. And if you're not actually interested in servers and just want to code but want to have this kind of system, then you can use, for example, Acquia for that. And here are a few of our customers that we have done AWS solutions for them. Yes, thank you. Do you have any questions? Siellä oli ensimmäinen.
Thank you for the presentation. You have nicely put almost everything in a high availability or services mode, but actually you are introducing single point of failure with the cron solution.
Well, in a way, yeah, but you can have a single cron machine also running as a single server in its own auto-scaling group, that if the server dies or is not available, it will spawn a new cron machine for you. So thus you can have high availability on that also.
Okay, I just wanted to clarify that because you introduced just one server in the graphics when compared to other servers.
Yeah, that was because we want to have just a single machine running the cron jobs. We don't want to have multiple machines running the same cron jobs at the same time, thus having a single icon for that.
Thank you.
Any more questions?
Was the code deploy one of the services provided by AWS?
Yes, yes, it is.
And you said that there might be some issues with Varnish. Are you using it, and how have you tackled the issue?
For this project, we aren't using Varnish because we have really high amount of data that keeps changing like almost every second. So in that case, it wasn't needed. There are some solutions that you can try out. For example, having Varnish behind the load balancer or on top of that, and write some custom script that keeps track of the IPs of either the load balancer or individual instances. But you don't want to have the varnish on individual instance, because that's kind of like overkill, and then the caching might be not synced with on every web server. But yeah, that is an issue with this solution that you need to like kind of like tackle on your own, depending on the project that you have.
Thanks.
Yes, I was thinking about how long does it take for a developer to put up this kind of system on an average?
Well, if you do it manually, I think I did it from scratch a few days ago and read through the manuals and actually documented while I was doing it, and it was maybe 45 minutes to have the elastic load balancer that scales up and down and the code deploy setup. But of course, on top of that, you need the RDS and Memcache, but those are in a way kind of trivial to have. Maybe like 10 minutes more to it, so maybe like 1 hour from scratch. But if you have the environment exported in to the JSON file, you can have it. I think it's something like 10 minutes, and you have the environment running.
Still another question. What about when the auto-scaling group spawns new instances of EC2s? How does the code deploy handle getting the site code into the server? How does that work?
Yes, the code deploy service actually deploys the code there and runs the hooks as the same way as you would update the existing web servers. So that's having when it spawns new instance, it automatically updates and runs those scripts for you.
Thank you.
One more question.
Hello. Because in our production side, when we clean the cache, and the service will be interrupted for a few minutes or something, because sometimes we update the live side, production side, and the style is missing, so we need to clean the cache. So you say that we can separate the web server and the clone in the separate server. So can this separate the clone server to the clean cache to the production side? And what's the extra work we need to do to support this?
Well, yes, it can clear the cache because the caches are stored in the Elasticache service. So all of the nodes or the web servers use the same. Just one moment, I'll bring up the image back. So all of the web servers, including the cron, use the same services, and one of those is the Elasticache. So using the cron machine, you can clear the caches that you have in the Memcache already, and also do the database update as everything are in those services, and every web server, including the cron machine, use same services. So thus the compiled CSS and JS are stored in the S3. Database updates are done on the RDS, and the caches are cleared from the Elasticache.
So, what are you running on the cron machine? Do you have like an Apache running there as well?
Yeah, basically we have like a Drupal setup with the Apache and possible additional libraries that we need for the admins only. So it's like a normal web server there in this customer case.
Okay, so you would have like Drush installed there, for instance?
Yeah, and then there you define the cron jobs that you need to execute there.
Alright.
Siellä on yksi.
Thanks, that was really interesting. But you mentioned at the beginning that Amazon takes some of the responsibility for this.
Yeah, and by that what I meant that when you're using those services, that if there is an issue with the service, the Amazon will handle the issue themselves. For example, if the like with the database, you can set it as to support multi-region deployment. That if one region goes down, it will have like a standby instances spread out to different regions, and it will automatically like fire up that standby instance, and then you have the database back up and running really fast.
Okay, but like in terms of general maintenance and updates, let's say PHP and Apache updates, is that something you're doing yourself? And if so, how much kind of time and resources does that take on your side?
Well, yeah, we do it ourselves. The AWS doesn't actually do the hardware or software updates themselves, but the RDS is different. That you can allow the service to do like some updates to the, for example, the MySQL version and to the actual server that it's on running. But well, yeah, how long does it take to update the, for example, Apache? It kind of depends what you're updating. But typical case, let's say you need to update the, let's say the Ubuntu version. That's somewhat big update. Then you can just create a separate machine that is not on the attached to the Elastic Load Balancer. Do updates there, check that it's running perfectly, and then create this image out of the web server and just configure the Elastic Load Balancer to use that image, and then you can like kill the existing instances and spawn new instances using the new image, and then you kind of minimize the downtime with that way.
Okay, thanks.
Any more questions? If not, thank you for listening to me and have a nice day at Nordics.